Good morning all. My name is Courtney Ford and I'm the RISCAuthority Administrator. Welcome to today's webinar, being the Insurance Challenges of MMC Modular Construction Methods, an Introduction to the RISCAuthority Questionnaire, IQ8. As was advertised, this webinar is being held to describe the basics of modular construction methods as well as provide practical guidance. Before I introduce our presenter for today, I just wanted to outline a few housekeeping notes. This webinar is being recorded. However, if you have any technical, IT or sound issues with today's webinar, please use the question panel to the right of your screen and I will do my very best to assist if I can. Please note that during the presentation, all participants will remain in listen-only mode. We encourage you to submit questions at any time during the presentation. I note that your questions will not be seen by other members of the audience and they will be passed on to the presenter and published as a Q&A document on our website. A reminder that all of our webinars are recorded and will be available to listen again via the webinar section of the RISCAuthority website, along with the presentation slides. And now I'm pleased to hand you over to our presenter for today, Ian Abley.
Hello there, Courtney. I'm looking for the share screen. Oh, here we go. Show my screen. Thank you. And let's hope that's
we can see your desktop.
Desktop, so I need to change that to change presenter. No. Right. I'm going to change the
Yep.
Sorry about this. I should have done it the other way around. I'm very sorry. Is that better now?
Yes, that's it. Oh, you might need to change. We can see two slides.
Yeah, I'm sorry.
It's okay.
Yeah, for some reason it's on my second screen. Sorry about this. I can't see how to change the screen. I've got two screens and I can't see where to change the screens.
No problem. If you go into the task window for GoToWebinar and it has show screen, you have the drop down. You'll be able to select whether it's screen 1 or screen 2.
Sharing. No, I'm sorry.
It's okay.
I can't see which icon this is, Courtney. Where does it say share screen?
In the sharing, do you have a sharing drop-down screen? Sharing drop-down menu in the little GoToWebinar drop-down box?
Yeah, I'm in the drop-down box, I think.
Yeah, there should be a sharing drop-down. And then that's where it has show screen, and then there should be a mini drop-down to showing which screen you're actually showing.
Oh, beg your pardon. Main monitor, is that the one?
That's still showing as the 2.
Is that the one?
Yeah, that's the one. There you go.
Is that the main screen?
Yes, it is. Yeah.
Beg your pardon. I'm terribly sorry, everybody. That's my incompetence. Thank you. Good morning. The presentation today is high-rise modular buildings and IQ8. And the purpose of today is to look at permanent stacked modular buildings to consider some of the safety and insurance perils, and the learning outcomes were listed in the invitation. And I guess the best place to start has been to think about what is modular, what's meant by modular, because we're not talking about low-rise houses in particular, though obviously that's where modular starts at the smaller scale. And some of the lessons learned at the boundary for low-rise housing are pertinent to high-rise, as we'll see. We are keeping in mind that some low-rise modular has suffered complete asset loss recently, including the and particularly the Moorfield Hotel in Bray in Shetland. Everybody escaped. It being low-rise, it was easy, but the hotel completely burnt through. We're not talking about medium rise. Let's, for the sake of argument, call that under 18 meter story height. But we are going to concentrate on high rise and the increasing push of modular to greater heights, and mostly in residential, but not necessarily exclusively, although modular is particularly suited for residential because of the room sizes. And again, we're bearing in mind the recent incident of the Paragon student residences in Brentford, which had to be evacuated after several years of argument over the fire safety issues in that development. That's an ongoing matter and is not necessarily public knowledge, the precise nature of that dispute. But it's a bit worrying that a development of 1,000 modules isn't habitable, and you kind of wonder how, given the long run of modular thinking, how that can be. I think is the question I've got really. The BRE has been pivotal from Loss Prevention Standard 2020, which was actually 2006. At 2020, it's just its numerical number, through to more recent attempts post Grenfell to 2018 and 2019 to develop a BPS 7014 standard for modular systems for dwellings in particular, rather than the innovative systems and elements and components of residential buildings, more broader sweep that was LPS 2020. There's a focus on the stacked up box, and that focus has been the stuff of numerous studies. I mean, the early one that comes to my mind was the Architect's Guide. When I was an architect, I'm not an architect anymore. The Architect's Guide was interesting reading in 1999, and Peabody pioneered their development. McDonald's was cited as an early adopter of Japanese methods of construction, and the then ministry were heavily promoting volumetric, as it was occasionally called, modular construction. Pioneered from the Steel Construction Institute's point of view for what was called light steel framing, though the weight is not light. A lot of the concern at the time was, how do you deliver that kind of modular? And much thinking in the last 20 years has gone into probably what the best publication in latter years. It was first published in 2014, but then in paperback 2 years ago. Mark Lawson from the SCI, Ray Ogden, who used to be funded, unfortunately died very young. He was funded by the SCI, and Chris Goodyear, who is at Loughborough University. This is a good read. I mean, it's worth getting if you want to know about modular. And it concentrates on what architects want to know. It concentrates on the box itself. That most of the guidance is directed at architects. There's a good literature that architects have taken on board themselves and turned into promotions of either collections of architectural schemes or marketing materials for their own practice expertise. And the SCI still publishes very good information freely on its Steel Construction Info website. But it's starting to seem a little, given the recent issues with the Moorfields and the Paragon, some of this information seems a bit naive, I think, is a way of putting it, and hasn't really got to grips with the practicalities of stacking boxes. In particular, the creation of cavities between the boxes. This diagram doesn't show the horizontal cavity between boxes, between the module units. It does recognize the vertical cavities, and also introduces cavity fire barriers, strangely at the facade, and that detail's just wrong. But at least it's recognizing there are issues between the modules, not just within the modules. So the emphasis within the modules is utterly on plasterboard for a light steel frame approach, because the plasterboard linings are doing a lot of work, as the Steel Construction Institute recognizes. The plasterboard is what people see as well. So people are concerned with the quality of the plasterboarding and the internal quality of fit out. And also, as you can see on the right hand side, the way modules join and have to be masked and finished at their joins. So internal qualities are of great importance. And because the modules are coming together on site, they have to be joined on the outside, and that's got to keep the weather out. So the way that the facade is finished is of critical importance. Proved to be quite difficult at the Pacific Park projects in Brooklyn with Skanska. Ended up with a very significant contractual dispute. So the inside of the box, the inside of the module, the plasterboard linings are doing a lot of work. They're also doing all of the finishing, but the nature of the plasterboard needs to be thought about. And I think that one of the most significant pieces of work that recognize this, again by Mark Lawson, Ray Ogden, and this time with Rory Bergin, who's a partner at HTA Architects. Within this paper, which is available for a small fee, it's been downloaded when I've looked at it about 7,500 times. So it's a significant paper that's often cited in much of the literature. There are 4 bullet points which make you really think about what's going on with a stacked modular building, particularly of a high-rise nature. And if you break those down, we produced a simple model. It's quite hard to visualize these things in 3 dimensions sometimes. The box is easy to conceptualize. It seems like you're just stacking up containers, but it's the junctions between the boxes and the way and the nature in which the stacking occurs, which is often proprietary. Every manufacturer's got their own particular take on a system. Some are very similar, but some extremely novel and almost patentable connections. But certainly the kind of system information that the modular manufacturers compete in the market over to make their own service and products better. These junctions become very important, and the paper, the 2012 paper, the first bullet point just recognizes that the stability of the module relates to the infill as much as the hot rolled steel. So the balsa wood part is obviously the hot rolled steel columns. The infill is often a very light gauge steel section. Here I've used dry lining sections, but sometimes they're larger gauge, 2 or even 3 millimeter cold rolled steel, but they're treated as an infill. The second bullet point is that the in fire, the floor, which is obviously, I'm showing here the soffit of the top of the module, but the floor above is influenced by the fire resistance of the soffit in the module. Well worth thinking about, because the ceiling inside a module may be a non-fire resisting ceiling below this soffit, so it's the actual soffit at the top of the module that matters. And as you can see here, where you stack up the next module, the paper quite rightly is concerned to point out that you're forming cavities. The SCI don't show that on their diagram online, but you create horizontal cavities as well as vertical cavities between modules. Sometimes the channels at their perimeter are, as here, flange out. Sometimes it's flange in, but the same problem remains, that you've got a cavity that continues from one floor to another, and a cavity within the compartment floor running horizontally, joining all of those, which extend to the external facade and extend back to the core. So as the paper says, they need to be considered for fire. And then you've got a very clear statement as the fourth bullet point in that paper of the way heat, so the insulation of the construction to prevent excessive heat getting to the hot rolled steel structure, which over 550 degrees will start to lose its strength. Now in primary steel frames, the primary steel is often protected by a rock wool or another insulation form, a stone wool fire protection, to prevent heat getting to the steel and melting the steel, or making it lose its structural strength over 550 degrees. Often in modules, the plasterboard, the linings are touching or in direct contact with the hot rolled steel. So heat transfer into the cavity and into the structural section is a matter of concern, as the paper points out. The paper also goes on to provide a couple of very useful diagrams that show the nature of the escape core, the concrete core that provides the wind bracing, which can sometimes approach the outside wall, can sometimes be extended to form corridors. Most of the time, you don't have the corridor formed in the core, you have the corridor formed in the module itself, often with service risers running vertically through that space. So you've got within that one module, you've got a room compartment, the segment of a corridor compartment, and a vertical service riser, all interpenetrating, all needing to be thought about as they go through the horizontal and vertical cavities. And those are assembled around what are often slip-formed cores. In this case, it was the cores are braced, as you can see, as the modules are erected, because you don't want them moving differentially as the modules are installed. Sometimes one core. Sometimes you see developments, of course, with slip-form cores that are nothing to do with modular at all, and it's just another technique for wind bracing a primary steel frame. And those structural standards for the core are Eurocodes. In fact, there are a number of standards that apply to modular, and this study that was produced, it was led by Chris Goodyear, one of the authors of the design guide for the BSI. It was a listing of all of the relevant standards that exist for other forms of construction that can be applied to modular. It's not just a matter of just buying somebody's system. There are standards that stand behind those systems that's a very useful guide to those supporting standards that manufacturers would recognize and have to work to. Similarly, there's work in progress in Canada, looking at the absence of information for high-rise modular construction, but trying to again, pull forwards the existing standards that can be applied to a sector that's innovating faster than standards are written. Arup have produced the first document in this new study. It's one to watch, I think, that the Canadians have long had CSA A277, I think it goes back to the 1970s, for prefabricated buildings, but now we're talking about modular towers. They're proposing to produce a standard that's specifically for the sector, which would be, it doesn't exist in Britain, but the Canadian effort is definitely something to follow. And they're system agnostic. They're looking at timber, they're looking at hot rolled steel frames with light gauge steel infill, and they're also looking at concrete. And concrete's interesting because the weight, it's usually assumed that light gauge steel is a lot lighter than concrete, but the advances in the concrete sector show that weight is not as necessarily just the gift of the steel producers. Equally, timber can be extremely heavy as a unit. One of the more interesting handbooks that it's actually been produced by Brookfield as a property developer, the owner of Multiplex, but back in Australia, Brookfield have taken it upon themselves to produce a very good guide, and this is well worth a read. Because I think the question we've got in Britain is which checklist, which set of information are buyers of modular systems, are developers turning to fill the gap in British knowledge and to take their development decisions. And of course, probably the most obvious thing I wanted to say today was, don't invent a new list. In Britain, there is a list. It's the legal requirement. It's Schedule 1 of the 2010 building regulations, and it's a list that makes most sense to follow because it is the legal requirements for any building, including a modular tower. Don't reinvent the wheel. Just let's explore what modular means in the context of the 2010 building regulations as they amend and as they are being amended. Now, the approved documents are extended beyond that Schedule 1 list, which is worth bearing in mind. And of course, most famously, most notoriously, Regulation 7 was extended to specifically look at the external cavity wall for fire post Grenfell, as a response to Grenfell. For high rise, it was explicitly high rise as relevant buildings, Regulation 7.4. And it's easy to get to a point where you kind of forget that actually Regulation 7.1, the old Regulation 7 on its own, but Regulation 7.1 applies to the whole of the building, not just the external facade. The facade that's often produced by somebody else, not the modular manufacturer. They have a split responsibility in a contract, which is something that we've tried to draw out of the IQ8 questionnaire. Who is actually responsible for the difference between the module and the core, and the module and the external facade, because these processes are not just different manufacturers, different contractors. They're also different designers often. And it's useful to also remember, I think, that the 2010 building regulations are not just looking at life safety. There are sections of the requirements, sections of that get transferred into the approved documents in England, Scotland, Wales and Northern Ireland have slightly different technical guidance and technical notes, which are subject of another. That's actually the subject of IQ7 from the which is downloadable now. but the difference in the different sections of the English approved documents and the requirements, they're not limited to life safety. So loss of the asset isn't part of property protection, isn't part of the approved documents or the requirements, but there is a precedent for other things other than life safety being considered. And I think if the Moorfield Hotel in Bray shows us anything, it's that loss of asset, it's one thing for a 2-story hotel to burn to the ground, quite another for a tower to be a complete write-off. And that fire in Bray was unstoppable. It couldn't be put out. The Bray construction was a SIPS panel, so it's timber and polyurethane, I think, core in the structurally insulated panel. But there are many forms of construction that that will be capable of being turned into a high-rise structure, and that's a neat timber. There's a push for timber at high-rise. Light gauge steel has been trying to open the market increasingly and succeeding in several towers in Britain already. But so there is no reason why you couldn't build a modular structure to high rise using a concrete core or a braced core of some kind, and stacking the modules around. But the doing so, you really have to interrogate what the requirements of the 2010 building regulations are asking you to do, and which is how we've tried to structure the questionnaire. The IQ8 questionnaire has got a front end, which are the higher level questions, and appended to that are a number of more focused questions that will take the structure of the 2010 requirements, Schedule 1 requirements, and drill down into a series of numbers with some increasingly focused issues to have to consider. The obvious one for structure being how the modules are supporting the dead load, how the columns increase at the bottom and reduce in sectional thickness at the top usually, how they're connected, how they're not using shims, for example, so the avoidance of shimming, and the maintenance of levels as you create the cavities going up through the building. So the connections of modules becomes of importance, and it's one thing to support the building. It's also a factor for the modular manufacturers to have to be concerned with the way that the modules are lifted onto the building and transported. So their own handling, the way the boxes are framed to take crane handling. Most structural engineers, I think, will be able to use existing Eurocodes to work their way through Section A. But if the structural engineer has worked through Section A without reference to Section B, to requirements B for fire safety, the structural engineer may be spending time developing a design that hasn't considered the things that perhaps a fire engineer for a high-rise building needs to consider. Structural engineers are adept at looking at steel in fire, and while disproportionate collapse is an accident rather than a fire condition, the ability of structural engineers to look at fire conditions is part of the design process. But at some point, a diligent structural engineer will recognize that there are fire engineering issues that they're unfamiliar with. A diligent architect would recognize that the particular fire engineering approach to a modular tower is needed. And probably one of the most onerous parts of fire safety, Part B in the requirements, is cavity construction. The the particularly B3 brackets 4, it's the unseen spread of fire and smoke through concealed spaces, and if this presentation does nothing other than point that out over and over again, I make no apologies for that. The cavity construction is the biggest problem in the modular tower. So our questionnaire has just taken a slightly different approach. When we get to part B, we've introduced a front end with B0, just because we wanted to keep the same numerical structure, and then work through the familiar parts of requirements B, adding handover information at the end. So the regulation 38 compliance issues, a front end anticipation of more than a fire strategy, but the need for fire engineering, and then with a view to the back end, the handover of the completed building to the responsible person under the regulatory reform fire safety order, and the statutory requirement for building regulation 38 information, not just an O&M manual, but specific fire safety information, a responsibility that's only going to become more acute. No, if you're dealing with a modular manufacturer, you'd expect the building regulation 38 information to be anticipated as a system. It could be one of the purchasing questions of a project. What information will we receive based on your system, even before you've awarded a tender? It's not just a matter of, what's one of the advantages of system building is that you get advanced knowledge of what's coming. If they don't know, then they haven't got a system. So we've concentrated very much on how extensive cavities are created vertically and horizontally, thinking about the gaps between modules, not just the room spaces, but the cavities. And that's not an innovation. That's understood by the BRE, has been formulated as LPS 1501, which is the full scale testing that's recommended, but it's not well recommended. It's not. It's referenced in BPS 7014. Now, remembering that BPS 7014 is only a draft, it's not actually a functioning piece of guidance, but it shows the direction of thought around the BRE and the people they're consulting with. But I found LPS 1501 slightly strange in that it looked at a three-way joint, not the four-way joint, because it's the presence of the fourth module making a cruciform connection, and you could argue that there are the need for an 8-way connection in some modules. But at least the 4-way joint would have shown the effect of heat, as the 2012 paper pointed out, the effect of heat on the hot rolled steel, because one of the failure modes in LPS 1501 is the extent of deformation of the floor structure in the compartment above. The amount of heat, there's a temperature failure mode, failure criteria, where a buildup of heat from one module to the next will mark the end of the test. So it would limit the fire resistance of the particular product. Now, I've never seen one of these done. That might be my ignorance. I don't know how many. I couldn't find out how many LPS 1501 tests the BRE have carried out. It's not very well publicized. You really have to look for it. I suspect they haven't undertaken many of those tests. Those tests can be carried out by any form of construction. Now, obviously, if you're Bouygues building in Singapore, they've committed to a concrete system, both for structural and for fire reasons, but also for, as we'll see in a moment, other factors. and that is currently the tallest residential tower. It's overtaken the residential tower in Croydon. This is soon to be increased. I'm sure there'll be another tower very soon along the way to claim the title of world's tallest modular tower. But this is the current example. It's also built in the seismic area, so the use of concrete as towers get taller might be a commercial factor that comes into play, where the SCI guidance to date has tended to concentrate on buildings of lesser height, but nonetheless high rise. But whichever way you do it, timber, concrete, or steel, the important thing with the compartmentation is to maintain that performance at the numerous joints and penetrations that will occur on the job. So there's been some excellent work by the ASFP, BISA, BISRIA, FIS, and the Gypsum Plasterboard Development Association, Gypsum Products Development Association, sorry. Looking at not only the quality of wall construction, particularly for dry lining, but also the importance of penetration seals. But this guidance excludes some of the cavity barriers and linear seals that are going to be needed in modular, particularly within the cavity, the horizontal and vertical joints, 4-way and 8-way joints that have to be considered. And one of the things that struck me reading the what I call the FIS guide, it's mostly been promoted by the fit out sector, the dry lining trade association, FIS, as a collaborative approach with the ASFP. But you look at a module and you want, where's the deflection head? You very rarely see a module with a steel module, at least, with a deflection head. Now on a concrete module, the whole of the wall is acting as part of the wall construction. For steel modules, there's a decision to be made that is the hot rolled frame doing all of the work structurally, and the plasterboard that's providing the compartmentation supported by an infill construction, a non-load bearing infill construction, in which case it needs a deflection head, and that has to be fire rated and fire tested as it would be on a conventional project with a primary steel frame or a concrete soffit. Or is the infill wall, which is often just one-sided plasterboard and very light gauge steel dry lining sections, is that actually performing a structural function? Because if it's completely wedged into the hot rolled steel frame, the load is being transferred down onto the light gauge steel sections. Now, that's bad enough in the situation where you've got just a non-fire situation where you've got load deflections from floor loads, impact sound issues transferring through the sections. But in a fire situation, the hot rolled steel is going to deflect in a fundamentally different way, which is the LPS 1501 test point. Without a deflection head, if the plasterboard opens up, whether it's at the top of the wall or, strangely, because of the nature of the floor in a module being loaded rather than the soffit at the bottom of the wall, if the plasterboard opens up, the cavity begins to be exposed, and if you haven't got a fire resisting plasterboard detail as non-load bearing infill, the gaps will open up. If they're using the sections to be part of the structure, they need to be more than a dry lining section. So that the IQ8 questionnaire is trying to get into the detail of exactly what the wall construction is made of as a pair, and they're always single-sided constructions because they're made from the inside out. They can have sheathing boards on the outside. Sometimes those sheathing boards are cheaper materials just to hold the insulation in place. The insulation is not shown on this model. But quite often the plasterboard's augmented with timber products, often OSB, inside the framed infill to take the load of cupboards. So the fit-out loads are carried quite as is conventionally done by dry lining companies using OSB or a timber board product. But whether that OSB is fire retarded or whether that OSB is a fuel load, a fire retarded OSB is just a fuel load that's been delayed in its action. There's a combustible materials load being built up inside the floor, inside the walls, inside the pair of walls, sorry, which makes one of the obvious things is to don't do that, is to take out the combustible load inside the cavities. But if you've got extensive cavities, you've got to have them fire stopped. Not cavity barriers, because cavity barriers implies a 30-minute integrity performance, but fire stop for the duration of the life of the structure, which could be 120 minutes, probably will be 120 minutes for a high rise. And the question there is, what material can you use to achieve that fire resistance performance between the modules that you can never get back to for the life of the building? What's going to last for 60 years, which immediately rules out intumescent materials, because maybe the market will develop intumescent materials that are proven by experience or credibly age tested to show a 60-year service life. At the minute, they don't exist on the market. There's plenty of stone wall products that would serve as fire stopping, but intumescents are not there. And so fire stopping at the end of part B, within the internal modules and thinking about how that fire performance is going to be achieved in the facade, does relate directly to the way the facade engineer has got to think about protecting the outside of the building from rain. It also affects the way that the pods are protected against accidental water damage, leaks in bathrooms, spillages, plumbing failures, any number of ordinary events, easily foreseeable events, insurable events that might affect products that are down the cavity that are very difficult to get back to and replace and repair if water damage occurs. Often the floor slabs, the floor panels in a module are running straight under the plasterboard infill panels. There's no upstand. There's nothing to stop water pouring down the cavity from a leak. So it's not necessarily just a limitation on the damage to plasterboard in one particular module. It could start affecting other areas lower down. It could start affecting structures that are susceptible to water damage too. So for example, the LNG factory has been pushing a timber approach. How water is managed in those timber modules is of critical importance, I think. Concrete boxes are one thing, steel frame another, and timber brings its own issues. And of course, you can get hybrid versions. You can get timber floors in steel modules. A lot of R&D has been spent on by LNG in developing their system. There's some excellent waterproofing systems around. They need to be asked for, and as part of the questioning of what kind of a system you're actually buying, you're being asked to ensure. Part C is I'll come back to Part C condensation risk in a while, because often condensation is discussed more in terms of thermal. Part D isn't relevant particularly, although it raises a question of the way that the building regulations are not concerned with the toxicity of smoke. They're barely concerned, except until you get to the approved documents, with the quantity of smoke, but the actual quality of smoke, the toxicity of smoke and its passage through the cavity is not discussed in terms of Part D. Something to think about, definitely, though, when Part B is being thought about for the compliance with the cavity rules, extensive cavity rules. Part E becomes much more important, I think, and a structural engineer could really give an acoustic engineer a lot of grief in the way that the modules are connected together. They might work structurally, but in terms of acoustic transmission, they may be very difficult to treat. I won't dwell on this, but it's also not an area I'm particularly familiar with. Acoustic engineering is a bit of a black box specialism, though I don't think it needs be. I think it's just that's the way the profession has developed something of a mystique. But perhaps acoustic engineering in modules is something that hasn't been looked at enough. Feedback from buildings in occupation would be very useful to see which kinds of systems perform better acoustically. But probably the main jumping ahead through the requirements, the main issue, I suppose, is not so much the acoustic insulation that is often glass wool internally to the modules, which I haven't shown on my model, but the external thermal insulation of the envelope, which does relate to Part C. So in the questionnaire, we've looked at the way the envelope is considered, and particularly the way the envelope has to be considered as the modules move. So the relationship of Part E and Part L back to Part A in structures, I think, is very important. So pulling together that information early on in a project is useful for design team. That may have already happened by the time the insurers are asking questions about a development that's already partway through its RIBA plan of work stages. And keeping the rain out is also a temporary issue. So there's been a lot of innovation, particularly in relation to Regulation 7 for the external wall, but there are even A2 membranes now that are available for temporary weather protection. Because remember that the temporary weather protection, even though it's going to cost a bit more, is actually on 5 sides of the unit, because it's getting trapped. It's wrapping in the box, the temporary waterproofing is kept inside the cavity, so it becomes something of a combustible fuel load when you double them up, module against module, inside the cavity. That is also affecting the way the cavity barriers have to be installed, because the temporary weatherproofing membrane can't run behind the fire protection inside the cavity. Otherwise, it's allowed a breach of the tested system for cavity fire stopping, the linear seals inside the cavities that have to wrap around all the risers, all the corridors, and between the modules, horizontally and vertically. A big piece of work. I mean, not a high value part of the contract. Often, fire stopping is often a smaller package on most jobs, but significant in its performance. And testing these things outside of full-scale tests like LPS 1501 is a bit tricky, because a lot of the product tests assume immovable object. They're tested between two lumps of concrete. So linear joint seals tested for as products aren't necessarily working as the system. So I think it's going to be increasingly important to watch what happens to LPS 1501 as and when and if the BRE manages to progress that guidance beyond the draft. Maybe the Canadians will get there first. Maybe the Australians have already done it. Looking at the two documents, I don't think so. I think this is a frontier of knowledge that needs to be worked at. And it's a frontier of knowledge that has to be handed over as answers at the end of a project, and is part of the contract. I mean, Regulation 7, service life, invariably part of a specification, the declaration of service lives and the performance of the various components, broken down into all the parts that have to be replaced and need to be accessible. Whether that's for water, better plumbing, so accessible risers, making sure that the seals can be replaced as they deteriorate, that leaks on particular joints can be addressed in service risers where they have to be connected module to module. They can be checked right the way through to the service life of the fire stopping, or even the service life of the waterproofing systems that go underneath tiling. I mean, all those things need to be accounted for, because we're dealing with a permanent, not a temporary. We're dealing with a permanent stacked modular building, and that if that contract is for 60 years, we need to know which parts of that building are going to last 60 years with no maintenance, last 60 years with some maintenance, or increasingly shorter periods of time with increasingly more maintenance, until you get down to the tertiary components in a system, which should all be known by the manufacturer. So you've got a full idea of how the permanence of that overall building can be sustained over a 60-year service life. Now, of course, that's exactly what the Build Off-Site Property Assurance Scheme was set up to achieve. It's an assessment scheme run by Build Off-Site BOPAS, where a system is assessed to existing British standards for service life, and the full performance of that system should be available before you buy it. It's online. The reports are available and updated by BOPAS. It's underwritten by BLP. Well, BLP are the insurance company that undertake the assessment, and it's underwritten by Lloyd's Register. A lot of work's been done on service life. That thinking needs to extend back through a checklist of all of the requirements in the building regulations, and to look at the gaps between modules, not just the module itself. It's one thing to make a plasterboard box, it's quite another to make a stack system that satisfies the A to Z list, the A to P list of Schedule 1 of the requirements, and notably Part B and Part C. So yeah, the summary of it's a bit of a wordy slide, this one, but they don't invent a new checklist. Stick to the requirement schedule that is the law in the 2010 building regulations, and develop that beyond the 2010 iteration of that requirement schedule into all the issues, including issues that are more than life safety, that the evolving building regulations requires. That's a very basic checklist. But once you've done that, you see that it's quite an in-depth interrogation of the system and know your system, identify the system that's being used, because the systems are incredibly varied. They're very proprietary. Some of the information is so proprietary that perhaps even BOPAS are not able to declare and publicize, fully disclose the nature of those systems, but they have to give an assessment under their own terms. And that assessment should be including all the inaccessible cavities, extensive cavities between modules. If it doesn't include those, it's not really following the guidance of the 2012 paper that is most people reference as the current thinking in modular construction. It's not a whole system. You've only got an assessment of the box. You need an assessment of the gaps between the box, because those gaps have got to be treated as the stack is built by somebody standing in the rain on a roof with a crane with several tons of material hanging above them, steering the thing in, so that 100% of all those junctions are achieved that day and will last 60 years. It's quite an ask for the installer of the modules. Obviously, check the currency of the BOPAS system assessment, and that should, you'd imagine that would include some declaration of the subordinate standards that the BSI study has identified, or the Canadians are becoming aware of, the Australians are becoming aware of, the kinds of standards that are in Britain, British versions of those issues. Should have a menu of standards that are part of the manufacturing of the permanent stack modular building. And some of those standards lead to tests. So one of the most interesting ones, I think, being the LPS 1501 full scale test. Even if you wanted to extend it to a 4-module test, rather than just fire testing of individual components or floors separate to walls in many fire resistance tests, because it's acting as a system. It's an important thing to not only achieve the requirements of the products, but to make sure the system is working. And unlike the prescriptive guidance in Regulation 7 post Grenfell, there is no prescriptive guidance for the internal cavities of a modular stack building. So you are relying on a system test of the units completely constructed with their various plasterboard and waterproofing and a build-up of finishes inside, which will affect the way the modules perform. Not contents. The test doesn't include contents, but the actual fabric of the modules matters, and the way it all works together with its deflection heads or not. So that's the summary. Hopefully, I've drawn out the 3 issues that we wanted to concentrate on: the cavities between modular systems, the fact that this is a frontier of knowledge, and there are things people don't know. There are things people aren't being told. Whether or not BOPAS know everything that a manufacturer does is a question, but there are things that aren't known, and that was part of the reason why the BRE developed and has struggled to develop the LPS 1501 test. But most of all, I think, try to keep it practical. Try to keep the issues focused on the practical solutions that lead to compliance with the legal requirements. Don't just invent yet another checklist. See how they relate back to the law. So yeah, thank you. There's a review process for the IQ8 questionnaire that's going to follow this presentation, and then the documents will be published online. The IQ questionnaire will take the form of a front end that with the higher level questions, and then an appendix that will drill down through the A to P list into increasingly detailed information. And at some point, you've got enough information because you've got answers back. But the high level questions are there to draw out some of the bigger themes so that you can understand the risks involved in the wide range of increasingly proprietary systems that are being offered for modular towers, permanent modular buildings, stacked modular buildings. So thank you. If there's any questions, I'll do my best to have a go at answering them, and hopefully I haven't overrun too much. Courtney?
Hello, thank you. We do only have one question that's coming from Alistair Smith. I don't know if you want me to read this out to you, or if you would prefer me to just send it to you and we can get that drawn up into a questionnaire document.
If you I'm quite happy to answer it if it's yeah,
no problem. Okay, we've got a few more coming in now, so I will read them out, or I can send them to you, whichever one.
Yeah.
But
pick the hard one.
How does IQ8 obtain details around repairability and techniques used in the event of different type of losses? This is also important to help the property insurer understand the risk and profile of the structure.
The repairability, definitely. I mean, that logically follows from what the system is in the first place. Repairing a concrete box, repairing a timber volume, or having to replace a lot of plasterboard and get access into the frame, they're very different things. So if we're talking about water damage, as with any plasterboard type of construction, you've got the need to replace the plasterboards all the way up. If we're talking about the discovery of missing cavity barriers, that's a totally different thing. I don't know how you'd simply get into the cavity again once it's stacked. So I think the answer to the repairability follows from the discovery of how the modules are constructed in the first place. I hope I haven't evaded the question there.
Not at all. I'll prepare a question and answer document so that you'll be able to write those answers down as well, and we can share that with the recording.
Okay.
There's only one other question, and it's from Dominic Thomas, and he asks, is IQ8 questionnaire only for high rise, or is it applicable to medium rise?
Well, I think it's applicable to low rise in some ways. I mean, the high rise have got the most onerous. It's the most onerous case, isn't it? And the higher it gets, the more onerous it becomes. In some ways, multiple cores, the increasing use of mixed use planning permission, so you get podiums with residential above, and then perhaps even a restaurant on the roof. There's all sorts of mixed use types of building that pose other risks, and some of the, as you get down to the medium and low rise, they become simpler. I mean, I suppose even it's more likely to find mixed use buildings in a medium rise situation. That a lot of the up to 6 or 7 story type developments contain shops on the ground floor, or a deck above which is residential accommodation. So yeah, I think the questionnaire is applicable. We concentrated on the difficult, even though it's not the mosts. Mosts are at low rise, but the difficult end of high rise, it could be that we can develop into some versions that extract and simplify down. But the front end of the IQ8 questionnaire, I think, is applicable to all heights of building. Whether or not you have to go into the depth of the appendix is another matter. The simpler the building, the less interrogation I think you're going to have to undertake to find out exactly what's going on. So that's a yes. I suppose it does apply.
Okay, we've got a few more questions coming in. What we might do is we'll take note of these questions and we'll prepare a questionnaire document. These will be uploaded along with the video and slide pack on our website.
Right.
If anyone has any questions, please do feel free to email them. You can send them to myself. My email address is cford@fpa.co.uk. And we'll pass those on to Ian and get an answer for you. But yes, thank you, Ian, very much for that.
No,
and
thank
we hope
you.
you all have a good day.
Thanks, Courtney.
Thank you.